So our project is image separation in 3D space and CT images. The goal basically being that we wanted to find a surface separating two objects that might be separated by a fine surface or might appear to be touching. The motivation behind this is because a lot of physicians have a lot of discrepancies when trying to separate such surfaces, and that can be quite costly. So the goal of our project was twofold. First, we wanted to develop methods by which we could separate them, and the second thing we wanted to do was develop an evaluation metric or method to evaluate them. The reason being that in the medical field, there's not a set method of how to evaluate such image processing. So that was our goal, to test different evaluation metrics and see how our methods that we developed held up against the metrics that we developed. So what we basically did was a sort of minimization process in both metrics, for which we used the Dijkstra algorithm, and then we also tested various cost functions in the minimization.
My project is based off available transfer capabilities, so what I'm trying to do is minimize the losses that are occurring as the power is going down the transmission lines. And so some of the solutions that I observed was wind farms. And so they do increase ATC, but they are kind of unpredictable. There have been studies about how we can predict it, but can't really do that until like the day of, 30 minutes before. So we looked at how can we add them onto multiple lines. So for example, for this system, I tried putting wind farms on these two lines, but what happened is the system overloaded because there was too much power being put out and the load can only receive so much power. So that's a possible cost. So I observed power electronics, so things like thyristor controllers that look like this, unified power controllers. The thing with that is it's more set to what the user wants, so they can put it, insert like we want this much power to go in, and it would kind of balance it out for you versus you being dependent on the weather that day. So as far as consistency, I would choose a power electronic device. They are complex to design, but it kind of balances out because the maintenance cost is kind of less than the maintenance cost for 20 plus windmills that you would have to maintain.
This project is about real-time MRI biofeedback. This is a picture from the human of this side, and we are using the snake algorithm to extract the edges of vocal organs and the lips, tongue, and the velum. And we are build this GUI to change the parameters of the snake algorithm to get better result of the extraction. And we also use this dynamicity to tag the speed of the image movement. And if it's moving faster, like here, here, and here, we may change our parameters according to the speed of the image.